Hello, everyone. Welcome to our webinar, Accelerating Value with Artificial Intelligence in the Financial Services Industry, brought to you by Mass Global Consulting. I'm Marcelo De Santis. I'm a strategic advisor to Mass Global. I'm really excited to explore this topic with you all today. I'm joined by Victor Casas, Head of Engineering, Data, and AI, who brings deep expertise in the subject. Victor, welcome. And you want to introduce yourself?
Yes, of course. Thank you very much, Marcelo, for the opening remarks. My name is Victor Daniel Casas Hernandez. As Marcelo was saying, I'm the head of engineering, data, and AI for Mass Global Consulting. I have been quite a while in the sector, mainly in finance, but also I have experience in manufacturing and in other verticals. Uh, Before joining MAS, I was the head of AI machine learning for global technology infrastructure in JP Morgan. So you can imagine that we have seen things as kind of battle scars, and we want to bring all that experience and all that learning into this webinar so you guys can, I don't know, taste a little bit of what are the trends, what is happening, what's going on, how can you power yourself, your company using AI. Today, the financial services, but you will see that we have a really broad spectrum of topics that can be even migrated outside of financial services, but we really want to focus in this particular vertical that we have a lot of commercial and business experience. So, yeah, Marcelo, to you.
Okay, well, thank you, Victor, for the introduction. And let me share the agenda for today now. We will start by looking at the latest trends shaping financial services, especially in how AI is impacting the industry, as Victor was mentioning before. Next, as a second point, we will dive into agentic workflows and how they enable automation and decision making within financial services. And finally, hopefully you're not shy, we'll wrap up with a Q&A session, to address any questions or thoughts you might have. So that's the agenda for the next few minutes. We hope you really enjoy the presentation and get ready with questions. So with that, I pass it over to Victor to lead us through the rest of the presentation.
Thank you very much. And remember, guys, that if you have a question that is just popping in your brain, type it in the chat. We will address everything at the end. So no question and no single rock will be unturned. Okay. So let's start. Before actually talking about things very particular in our topic, normally we really like for the people that are engaging with us to see and understand what's going on with AI. So this is what is going on in AI. It's extremely interesting, and let me explain what does it mean, what you are seeing on the screen. So chinchilla, I don't know if you know what's a chinchilla. It's a little almost like a rat type of animal. In AI, we love to have those type of names. That you have Elmo, you have Bird, which are the Sesame Street kind of characters. So in AI, we're a little bit geeky about how we name things, and this is called the chinchilla relationship. So the chinchilla relationship basically is telling you how much return per token you should have in a model. What does it mean? You have a lot of data, so every single new data point you put into your model, it will give you a return on an expected task, right? So if you move in the chinchilla region, it means that you are optimally training a model, meaning that new data point gives you X amount of percentage. That's good, right? So imagine one data point, it gives you 0.1%, good. But if one data point gives you 0.0001, it means that your data point investment is not there. So something is wrong with the model, and then you change. What has been happening, I don't know, in the 2010s, basically, almost the half of 2020s, which we are in 2024, is that the chinchilla law has hold for almost every single model, meaning more data with more parameters, then the models get better performance. Today, in the AI industry, we consider that chinchilla law is destroyed, like is no longer applicable. And if you don't believe me, Google Gemini 3.0. Gemini is the LLM or the model of Google. Google Orion, which is GPT-5. The companies, OpenAI, Google, and all the other labs are saying more data is not better anymore. Now we don't know what to do. So they have these huge data centers with billions of dollars in GPUs that they are saying, okay, what do we use this for? And you are seeing the, the second thing of I told you so. There has been really a lot of, let's say, AI researchers like the top, particularly Jan LeCun. He's the head of AI research in Facebook. And he has been saying the models of today are not going to be good for tomorrow. But obviously other people are like, no, we are going to scale. We want that, this and that. Now everyone is hitting the plateau. The guys from OpenAI accepted, the guys that left OpenAI accepted, Google is saying the same. Now everyone is like, okay, if now more data is not better, now what do we do? At least in the AI space, we expect discovery, meaning that today all these models run in a particular architecture. It's called the transformers architecture. I expect personally that those transformer architectures won't be the one that are going to stay. So probably we will see new breakthroughs on more philosophical and architectural understanding of models, and we are going to see probably a plateau, hopefully 1 or 2 years so everyone can adapt because there's a lot of change, and then we start again. So just wanted to kind of bring you guys this particularity. I know it's a little bit technical, but more than happy to answer in the Q&A. But we really want you to be kind of in this kind of the gossip of AI. So this is what's happening under the research labs in general. Now, as Marcelo was saying, we're going to start with the paradigm shifts in general. So normally in financial services or in AI, let's say AI in production or applied AI, the focus has always been in traditional machine learning. But what's traditional machine learning? So that's a simple graph there that I'm going to explain. Traditional machine learning is basically you have data, you have a model, and you tell the model what to learn. So if we go to the first piece of the graphic, we see there are apples. You tell the model these are apples. So the model learns, okay, if you give this rounded red thing, what is it? An apple. Rounded red thing, an apple. Rounded red thing. So it learns. Now, when you show a banana, it will say, no, that's not an apple. I don't know what else, but that's not an apple. And when you show an apple, hopefully it says an apple. That's called supervised learning. And the second thing that is called unsupervised learning means that, look, here's something, there's data. Can you tell me something about it? Do you see something? And normally they find patterns and they separate things. So as you can see, you have apples, you have bananas, and you have what I believe are peaches or mangoes. And that has been probably since the 60s how we approach things. But the power of compute, the data available has been migrated all the AI into reinforcement learning. So what's reinforcement learning? Is the way that we humans learn. And what does it mean? We have an agent. An agent means something that can take action, observe the world, and it has a reward system, meaning that a reward is like, yeah, good. No, it's not good. So this agent starts touching things and say, I don't know, imagine that eating is good. Okay, good reward. But not sleeping, that's not good. So you put a negative. So there are mathematical frameworks there that help an agent learn. And that type of framework is what today is called generative AI. So underneath generative AI has a lot of reinforcement learning, but it has a little bit more technicalities. Why do we say this? Is because in the left, you have the traditional way. In the right, you have the shiny object. And why is this relevant? Why is this shift happening? Obviously, you probably are hearing everywhere, generative AI, ChatGPT, GPT this, GPT that, Claude. So all of those things that you hear are from the reinforcement learning paradigm. And they are really media covered, but the question is, where is the actual use cases in production? And probably as you have guessed, 90%, 90% of the use cases are in the traditional machine learning still. We have a lot of clients, and the clients have mainly traditional machine learning use cases in production. However, the same clients are exploring, can I do reinforcement learning / can I do generative AI in production? It's really complex to deploy generative AI. We know how to, we have done it. So yeah, there are expertise in the market, but normally, if you're just testing the waters, if you're like, you know what, I really want something in production, but I don't have the expertise, it tends to be the easiest way to get into machine learning, to introduce artificial intelligence to any company through the traditional way. What the traditional way? I have data, I have something that I want to learn, let's deploy. And funny enough, that's when the ROI is higher. Why? Because the use case is really well defined and specific to a company, that it tends to be extremely powerful and extremely performant if the data is there. And that's we believe that the return is there. Now, you probably are wondering, okay, Vic, that's good. There's a lot of theory. I don't want to feel like in a lecture. I'm a practitioner. I want to know, what have you guys have done? How does it look like? So one of the things that we wanted to bring to everyone is a model that we implemented. Model that we implemented, it's a credit score that we put into production, but the particularity of this credit score is that it's a credit score for agriculture people. What does it mean? The agriculture or the farmer doesn't have access normally to the traditional banking, meaning that imagine a farmer having access to banks or a farmer having access to credit cards. No, it doesn't work like that. Normally, they have all cash or small reserves with a small bank, if so. Or maybe we have been seeing a lot of the pay wallets type of data, so they transfer themselves between pay wallets, but that's not bankarized. Meaning that if they want to grow their business, they cannot. Why? Imagine that you go as a farmer, you don't have credit history. Equifax tells you your credit score NA, not a number. You get denied the loan. So this company was trying to say, you know what, we want to democratize in the agricultural sector for really hardcore farmers that do coffee and certain type of beans. We want to be able to give them loans, but they don't have traditional financial data. How do we do? So what happens is that we created what we call an alternative credit score. Why alternative? Is because we use alternative data. Remember, any data can work as long as the performance is there. We have satellite data, we have geographic data, we have data of the actual soil, we have people data, behavioral data. So it was a beautiful data set. And what we did is that we built a model of a credit score as Equifax, as TransUnion, as Vantage, as whatever, because we kind of validated to see the behavior of all of these people and how do they score. It was, for a first approach, it was really, really good, at least in my humble experience building credit scores. And we noticed really interesting things. And that's the beauty of machine learning. Sometimes you as a human, you don't know what's going to pop up. And one of the things that pop up, at least in this data set, is one variable that I remember that I told the CEO, look, I don't know why is this happening, but I have to report that. Is that if a female or if a woman is present in the leadership of the farms do better. You wouldn't expect, and probably a bank, it doesn't even capture that. But if a woman is present in the leadership of the farming family, then the farm does better. And what does it mean does better? It produces more, the payment is more behaved. So that was an interesting finding. I even tell them, look, this is something that you can even publish in a journal because a behavioral finding that is really unexpected. So that's the beauty of machine learning. That's the beauty of AI, that the data is the one that speaks. We humans sometimes have opinions, but our opinions are subjective to our own experiences. However, when you analyze data, the data just speaks whatever is there. So it was a beautiful thing that that we did, and this is deployed into production, and they are using it right now. So I hope that you have fun with this. Now, we already saw that there's a lot of things here. There's a lot of things that people are doing, and maybe you are wondering, if there are so many things to do, what should I do? What should be my first one? What should be the first win that I can have for my own company? So we brought what we call proven use cases with high return. These are things that normally clients or the industry implements. They are the first, let's say, use case that goes into production. And when it goes into production, a lot of good change happen in the company. So I'll go one by one. Alternative credit score, obviously, you already hear from myself there. Is basically you build classification systems because you don't have traditional financial data. That is why it's called alternative. And the alternative is also the way that you go into alternative clients. Because if you're always looking at the same data, you're always going to look at the same clients. But now that you are like, oh, you know what? I have different sources of data. What type of people can I go? So imagine if you can process, I don't know, pay wallets, or whoever has Sale, whoever has Venmo, whoever has Rappi, whoever has Mercado Pago. Like imagine if you can process that to actually give loans to people, that probably the population of potential clients just grows really, really big. And that's the whole point of doing an alternative credit score. You can expand the potential client acquisition base, which at the end of the day, if you do it correctly, is good revenue. And second thing is anomaly detection. Anomaly detection is super versatile. Just a disclaimer that I think I need to do. That's my specialty in artificial intelligence, anomaly detection. And I have implemented a lot of anomaly detection systems in a lot of places. And they are really a really, really good first use case. Because anomaly detection normally tells you what is weird in the company, what is strange in the company. And it can be used, how do you find a strange? Whatever the algorithm thinks is strange. It could be a strange transaction. It could be a strange behavior. It could be strange clients. It could be strange movement. So literally anything that goes out of the normal can be subject to an anomaly detection system. So it's really good for first line of defenses in cybersecurity, or first use case of fraud detection, segmentation of clients, client behavior. There's a lot of use cases there. So we really recommend implementing an anomaly detection system so you can pass a lot of data through that and start learning from the things that we humans don't see. And the third one that it tends to be really used is that every company does forecasting and planning. But you not only do forecasting and planning in the financial FPA, meaning budgets, but you can do forecasting and planning of supply chain, of inventory, of client, of demand, of maybe if you're a software company or you're a payments processor, Black Friday is coming. Can our systems hold the transaction that will come in Black Friday? Sometimes you cannot, sometimes you can, but that forecasting will be able to, okay, I will pre-provision infrastructure. I will prepare my infrastructure, prepare my application so I can process every single little thing that might come in a Black Friday as a payment processor. That's really, really interesting. Normally, that helps in the resiliency space a lot. At least that's the experience that we have been having. Now, following a little bit more, I'll say deeper into this is a little bit more closer to the state of the art of what people are doing. A lot of people are doing graph analysis. So what's graph analysis is that when you build a network of things. A network can be, imagine books, like there's a lot of graph analysis in books or Wikipedia articles, like the internet, I don't know if you guys know, that's a fun fact. It works like this. So web pages point to each other, so they build a graph, and that's how Google works in the PageRank algorithm works. And you can build a lot of good insight with just graph analysis. Today, with the power of Gen AI and graph, those things combined are blasting through really big pieces of knowledge. Like I read something that with, I mean, I say only, but I know it's a lot of money. I think with only 5 million, you can index the whole internet and have your own Google powered by Gen AI and Graph. So that's a really beautiful use case. And having the internet for yourself, like imagine duplicate Google for 5 million, is definitely something. I mean, I think it's not that expensive given the fact that Google is a $1 billion company. Customer segmentation, that's every single time people are trying to learn more about their customers. Unsupervised learning is the first step, but now with the other techniques that we have in Gen AI or anomaly detection, you start kind of applying several layers into a customer segmentation space. So you understand better price patterns, better certain preferences, better certain segmentations. And at the end, fraud detection. Fraud detection is something that is extremely common in the financial services because fraud can be whatever. It can be insider trading if you're in the asset management space. It can be actually a fraudulent transaction if you're in the payment processing. It can be a credit card, like anything can be fraud, whatever it is concerned to you. And the fact of fraud detection is that is bottom line. What do I mean by that? I mean, probably you know, but I'll just say it. Imagine that you're running a 5% fraud budget, but if you can actually lower the budget, meaning that you have actual savings because you don't have to pay from your own pocket the X percentage of transactions that are fraud that you have to pay. So imagine if you run 5%, you go to 3%, that 2% is actual revenue bottom line that the company is making. So these are really powerful use cases that when they go into production, and besides that, you have a better customer experience, obviously, is literally bottom line. Um, so yes, I hope that this excites you. I can't talk every single day and hours around all the use cases that we implement. I'm really passionate about that. Keep going. So this is for you, my friend Marcelo.
Yeah. Well, thank you for all the insights about the use cases that you have worked with mass clients in the recent past. That's pretty insightful. Thank you, Vic. So now we would like to get your thoughts, if you're in the audience, with a quick poll um, that you have here in the screen. Now we give you a minute to answer, but here the idea is to really understand what's the level of AI maturity that you're seeing in your organizations. Are you at the feasibility study phase in where you're trying to really understand what to do next, or you have that in clear and you are moving forward with a proof of concept to really, build some basic capability and understand the value of what you're trying to do. Or maybe you're, beyond that, right? You're testing an application of AI or generative AI, or maybe you are even beyond that. You are already having any of these use cases in production and you are enjoying the benefits for your organization, for your business, for your people. So give you a minute just to answer, and let's see then if we can take a look to the results. If not, we keep going. um,
Don't be shy, guys. It's okay to say feasibility. Everyone started there. And if you're in production, congratulations. As a fun fact, 97% of the projects fail to reach production. At least that was a metric in 2022, I believe. I don't know the metric right now. Gartner has it, but yeah, that's an interesting thing.
Victor, while we wait for
Yes, sir.
the team to provide the input, I mean, what have you seen that is critical to move from proof of concept or above proof of concept, right? I mean, what has to be in place in your experience?
Yeah, that's a really interesting question. So we have in mass what we call the AI assessment. And normally, the assessment goes into what's the probability of you getting into production, right? And production also means that sustained production, meaning that it's going to last for a long time. First, do you have the people in place, meaning that someone needs to run this or at least use it? That's the first question. Because if you don't have people, it won't get into production. I mean, it could get into production, but then no one will use it or no one will maintain it. You don't want that. Second thing, and probably this highest in the ranking of needs, is infrastructure. The infrastructure needed to run AI is non-trivial. You either need the cloud, or you need good clusters, you might need GPUs. So there's specific infrastructure that you need and want in order for you to deploy into production in a, let's say, decent
Mhm.
SLA and everything. And the most probably important and what everyone is wondering is data, right? For you to scale from proof of concept to the actual production level model, you have to have a really battle tested model. And for that, you need enough data to test and train the whole thing. Companies, sadly, I'll say sadly, I mean, let's just accept it. That's reality. We are in a wave of data modernization. So everyone is implementing a data strategy, cleaning the data, because there's one famous mathematician. Actually, he was a statistician that says uh, garbage in, garbage out, referring to models. It was Cox. Uh, sorry, George Box. And it's definitely like that. If your data is not in good shape, if your data is toxic, you will have toxic models. If your data is in a really good shape, you have really beautiful models into production. And ideally, when you go from proof of concept, as you can see, testing, a lot of models fail. Oh, that's beautiful. That's proof of concept. Okay, let's battle test it. Boom, it starts hallucinating, it starts unperforming. If it hasn't seen some data, it cannot generalize. So there's a lot of particularities on things that can go wrong, that will go wrong in the testing if the data is not enough. So definitely those are the three ones. And as a summary, first data, second infrastructure, third people.
Excellent. No, thank you, Victor. I got the results. I mean, they're not statistically, we said perfect given the number of responses, but 50% of the responses are on feasibility. So you were
Okay.
right with your gut feeling, Victor. 30 plus is testing, and the rest
Oh,
is
wow.
proof of concept. So not bad, right? I mean, again, the number of responses is not highly relevant from the statistical perspective, but that's where we are with the audience. So that's good to know. Thanks
Okay.
for answering. Thank you for answering, and we keep going with the presentation now. You have more information to share.
Yeah, thank you. And thank you for the audience. I'm happy seeing that people are in proof of concept and testing, because it means that now you are getting hands-on keyboard. And that's how you get into production. One day, someday you'll get into production. So let's keep the hope together. Let me see. Okay. So these are really interesting topic, and probably you are going to see a lot about this, or you are already seeing a lot about it. Is the concept of an agent. So remember that we say, oh, in reinforcement learning, you are an agent that you learn. Okay, now we super overcharge that, because now an agent is a thing that has actions to do. So let me explain. We have here like this chart, and I think this chart is really interesting, because you are the user and you ask a question. How many users churn this quarter? Meaning, how many people leave our product? And you ask that as a human being. So this thing that you see here, LangChain agent, LangChain is one of the frameworks of agents. It has access to Python. It has access to the internet. It has access to SQL databases and SQL queries, meaning that it literally has tools to use and process. So what does it does? that's what we call agentic framework, is that this is software still. And if you are wondering how does artificial intelligence looks like, or how will general artificial intelligence looks like, imagine iRobot, like those type of movies, it's code. Everything is code. So this piece of code that is running start asking, okay, I have a question. How do I resolve this question? So there's a lot of frameworks that, for example, chain of thought is, okay, first I need to understand the question. Second, I need to understand the entity. So it starts doing a list of tasks that it needs to execute. After it believes it has the task, it could call a friend, meaning it calls another agent, say, hey, agent, is this a good task? And another agent will say, yeah, that's a good task. Let's call LLM as judge. So if the task list is okay, then starts executing. Okay, what is the question? Solve the answer. What are the entities? It solved it. Okay, now I understand what is the query that I need to do. So it literally goes to a database and it say, oh, I don't find this entity. It goes to the internet. So it starts actually doing things to solve the questions. After everything is checked, then it will say, okay, I have the answer, and the answer is 542 users. So this is the beauty of what's going on today. And that's only possible because today agents can make tasks and understand where to look, where to execute. And that's called agentic frameworks. Prominent technologies or technologies that are really important for everyone to understand in the left are kind of the two most powerful, in my humble opinion, LLM providers. LLM is generative AI, like the core brain model. And in the right, there are frameworks. What's a framework? Imagine like a box that encapsulates everything. LangChain is really popular, but personally, I think the SPY is going to go into the sky. So if you're a company that you are already having something of this into production or you want to explore, don't sleep on the SPY, definitely pay attention. But LangChain is probably where everyone is going. So things that you really, really need to consider if you want to implement agents in your company. Prompt management. Why prompt management is important? Prompt is literally the text that you write as a human. And the text that you tell the LLM to do as like orders, right? It has grown so much, the amount of prompts that you have to do for LLMs to act correctly, that now prompt management is becoming a thing. So you have GitHub, you have code management, code repositories. Now people are talking about prompt repositories, prompt management, because it's growing and growing and you need version and you need to track them. The second is the agent framework, as I was saying, LangChain or the SPY. You choose whoever you want. The third one is scope and personas. This is the interesting part. Not every single thing is agent, let's say, automatable. Normally we call it agent vulnerable. Why? Because there are things that cannot be agentic automated yet. For example, reading documents and doing summarization of the documents, that's going away. Agentic framework, boom. But something as, can we come up with the strategy of 5 years of our company that would take into consideration the economy? That's definitely not something that an agent can do. So you start seeing tasks that are vulnerable and non-vulnerable around that. Ideally, you identify the vulnerable ones and apply an agent to that. So you can liberate the brain power of every other human to actually go from the non-vulnerable that tend to be more strategic in thought. There was a claim of someone in Microsoft that there's going to be, I think, 10 agents for every human being in the planet. I don't believe so. I don't think there are that many tasks to be agentic, but now those type of claims are over there. So, and I do want to kind of hear the opinion of Marcelo. Marcelo, what do you think about this? Are you scared? Are you afraid? Or it's more exciting to you?
I have a couple of things to share, right? I mean, I was checking the questions, right? And there is a question about RPA, right? And when do we graduate from RPA to agents, right? And when you were sharing before, Victor, that many of the companies that we are uh, consulting with, they, they still are trying to manage to have the right data. My point of view on agents that can be actually acting on behalf of humans and making business decisions, I think it's a vision at this point. I, I I struggle to think that in the short term there will be applications in where agents will take over an end-to-end process without any human interaction. That's number one, and the reason is because you need to have data that is relevant and have some time to test the behavior of these things. But on the other side is I'm sometimes I'm very pragmatic with these things. If you couldn't automate a process up until now, right, with the tools that we have, why do you think agents will be do anything different, right? So if we couldn't automate the process to a certain level with the tools that we have today, I'm sure it's because the process has been very complex or requires a lot of human interaction.
Exactly.
And would you really move into agents right away? I feel that it's very difficult to believe, right? But it's a trend. Um, Models are improving. Software engineering practices are improving. Chips and silicon is improving. So I do believe that that the future of these things will evolve. I think sometimes we're trying to go too fast and we're not patient enough. But not today, maybe the day after tomorrow, maybe yes, right? That's what I think about agents. Yeah.
Yeah, and I totally agree with you. And you bring a really interesting point around RPA versus agents and the fact that nothing, like not everything is automated, right? And why agents are becoming so famous is that agents, one, accept vague orders or vague instructions when software really needs specific ways of having inputs, either by a template, parameters, like those type of things. That's one. And the second is that in theory, in the RPA, even though you can have if else, you can have control flows, quality checks, it's still a, let's say, a sequential process. While here, you have the recursivity, meaning that this agent can evaluate, have I done the task? Is this an acceptable answer? Have I done? Good thing is that you won't get the task, you won't get the result until the task is actually done. Bad thing, you won't get the result until the task is actually done. Because if the task is extremely complicated or the task is extremely ambiguous, the agent will just be there thinking, and testing you and probing you, but thinking, right? So it's one for another. Personally, I like the fact that you have recursivity and you have critical thinking, and that's why there's a lot of frameworks called LLM as judge, because you have another LLM watching the another LLM. So imagine like a supervisor and the one that executes, and that allows a little bit of more complex tasks to automate. But as you are saying, this is not a magic bullet. Everything is still not something that we can automate. It's just, let's say, imagine like RPA expanded or enhanced with
Mhm.
AI.
Yeah, and maybe keeping the human in the loop, right? I mean, you can
Right.
build agents and as copilots, right? The reason we call this, many times things like these copilots is because the pilot is still the human, and the agents or the models are, augmenting the human, and that
Exactly.
augmentation could be a feedback loop that actually makes the
Exactly.
agent, through time, more independent and autonomous, right? It's not different to what happens with autonomous vehicles, right? With
Right.
the hours of cars driving in the streets and recognizing patterns of images and situations, and all the telemetry that you have in a car. The system is becoming better and better, but it took a few years, right, to get to a point
Yes.
in where this is autonomous. And on the other side, even if the software is almost perfect, then you need to deal with the human apprehension, right? To let the car drive by yourself without you paying attention to the road. So there is also a human change management aspect that it's present not only in autonomous driving but also in agents within organizations, I think. Yeah.
Yes, and I totally agree with you. And funny enough, now that you mentioned human in the loop, there's actually a reinforcement learning framework called reinforcement learning with human feedback. And that's kind of the most used framework. So definitely, even in AI that people love to do AI, we still consider the human as the ground truth or the golden source of, I mean, we suppose that the human is well intended, rational, well behaved, there are those suppositions, but given those assumptions, the human is still basically the god for the machine. Going a little bit into the second use case is that in mass we have done agents, and this is kind of one of the most beautiful, that's my personal view, use cases that we have implemented. And that's when you see, I don't know, you see the power of this modern technology. So basically, in the finance sector, what you can do, remember that we talk about personas, we talk about tasks. So basically, you can start rationalizing a particular seat in a company as a amalgamation of tasks, meaning that a risk manager does, I don't know, let's go into the Basel framework, identifying the risk, quantifying the risk, and mitigating the risk. So identifying is all about monitoring. So you can build an agent that monitors. Quantifying is about actually measuring the risk into what's the volatility of everything, so you can build agents that do risk assessment. So that's beautiful because you can start kind of slicing all these personas in particular tasks. And in mass, we have already done that, and it's impressive, to be completely honest. Like, we have the earnings report analysis and the financial report generation, and the fact that you can generate a report in 2 minutes. But when you see what's under the hood is that the agent actually goes to third-party data, it goes to the market, it goes to social media, it goes, takes the earnings report, the 10Ks, the 10Qs, Bloomberg, all of that gets condensed, and the agent starts reading it and saying, this is the thing that I believe is happening with the company, and generates a PDF report. Obviously, when I say I believe, is there's code underneath, and you can tell the agent how the agent process and how the agent believes those things. It's not like, oh, really, there's intelligence there. No, there's a prompt there that is basically telling the agent how to process there. So as you can see, prompt engineering. But it generates the results and it generates the reports. And we have seen a lot of interest from our clients to, that's the thing that I want. Some of them already have them, but then they have complications. Like, okay, probably you have heard about it, the hallucination complication, meaning that it reads information and it just creates information out of nowhere. So that's something that you have to mitigate. Gladly in mass, we have kind of methodologies on how to mitigate hallucination. Uh, Not to 100%, because no one knows 100%, but we can do 9.99.2939s in certain particular task, obviously. So that's really, really, really interesting. But things, if you, let's say that if you want to implement agents, consider the data. Data is important. If you don't have good data, the agent won't do good things. The second is, do you know what the agent needs to do? Because you can, agent, go and clean the street, but if no one has told what does it mean to clean the street to an agent, probably would just try to guess. The third one is the LLM that you use. That's definitely important. There are LLMs that are more specific to finance than other LLMs, or you can even tune an LLM to be super financial specific. You can see the news in JP Morgan. They are releasing LLMs that are finance specific. So in case you want to use them. And at the end of the day, you need to deliver this to a human. As Marcela was saying, the human in the loops is super important. So the way that you deliver the information or the way that the agent interacts with the human is really important. So ideally, you should consider that. So yeah, that's all what we have for today. We wanted to open space for Q&A, but I guess that we really want to know. We covered a lot of things here. Is there something that piqued your interest more than other? And we want to know from you guys. Do you have, Marcelo, any in particular use case that you prefer?
Sorry,
At least that you're more curious.
I was speaking and I was on mute.
That
No,
happens.
the one I like is the first one, and the reason is specifically for banks that are, not the large institutions that they have many resources and large teams, but credit unions, tier two banks. If I were in any of those organizations, I will use the data I have to have my alternative credit scoring system. And the reason is that I think it's good for the business, it's good for the customers, and also shows that you care about your customer base, right? You are actually basically customizing the credit scoring to the behavior and the patterns of financial behavior of your customer base. So I think as long as you have the data, as you said, Victor, that's one I personally like. Um, Forecasting for many industries is always important, specifically if you're in a public company. Forecasting becomes um, an extremely important capability to have, because you need to go to each earnings call and tell the market how much are you going to sell, and it's going to be your cost profile, things like that. So 1 and 3 I like. Fraud detection is obviously very important in the financial industry. And maybe a question for you, Victor, on this one is, how do you see false positives, right? I mean, what I heard from colleagues in the industry is that, yes, they are maybe using tools or building their own fraud detection systems, but the biggest challenge they have is the false positives, which actually piss off customers, right? When you get those calls about,
Right.
I think there is a problem in your account. They say, no, I'm just buying something, or I just been traveling, and that's the reason that I am using the account from another country. So I don't know what you think about that one, right? But that's what I hear from many colleagues in the industry.
Yeah, that's an amazing question, right? And that's what we say that is so important to think about the integration of the machine learning system into the whole environment or ecosystem. Because you want to have a fraud detection system, but you don't want that to be the whole system, meaning that a transaction might get flagged. Hey, this is strange. This might be fraud with X% probability. So you don't let it pass, but then you do as you said, not blocking, but sending the test message like, hey, I detected that this strange transaction is yes or no. Do you want to authorize it? If you hit yes, then that's it. But what happens normally, what I have seen banks and what we have helped payment processors is that you have a main queue. The main queue is the production one. It passes and it gets classified. If something is potential fraud, it goes to another queue and you wait for it. So it's queued. Then you get the yes or the no. Yes gets processed. No, it actually gets declined. So that piece is just software. The machine learning is done. The machine learning is
Mhm.
good transaction by transaction, but everything else is software. So that's when we invite people like, look, machine learning AI doesn't exist in a vacuum. It exists within an environment, within a technology, within a change management framework, within a customer. So you have to think of all the things and impact. So I really, really like this intervention, and you don't want to become annoying, right? And
Mhm.
sometimes you have to budget, okay, how many errors I will do, or after what threshold. Like if something is 99% potential fraud, yeah, you want to flag that. But if something is 10% potential fraud, do you really want to alert on 10% potential fraud? I don't know, that would be a business decision.
Mhm. Absolutely, absolutely. So let me share with you the results. I mean,
Yeah, I'm
more
super
than
curious.
40, more than 40% is capacity forecasting, and then you
Wow.
have 30% for network analysis and 30% for
Oh,
customer segmentation. Are you surprised?
wow, I'm surprised, but I'm actually really happy because network analysis is kind of the geeky use case, and it's the one a little bit more complex because you require a graph. So I'm really happy that people are enjoying network analysis. And customer segmentation definitely is super important and is revenue based. So I expected that. And capacity forecasting is a really, let's say, traditional one, but definitely interesting that network analysis was on the top. So it seems like we have a really sophisticated people listening to us today. Thank you.
So Victor, I start with one of the questions that we have in the chat that it's
Okay.
I try to represent it as close as possible to the original question is if all LLMs give more or less the same response, right, to a certain extent, is it data for companies the differentiating factor in getting the benefits out of generative AI or AI products in general?
Yes, you are hitting the nail there. So when you study how LLMs get trained, normally the baseline is really similar. You have Wikidata, internet, they even tell you the percentage of each data set they are using to train, right? But the internet is, I think we already run data from the internet. Like the internet is already in the LLM. So the question is, okay, what else? How do I get the advantage? And that's when that comes. So there are other methodologies that are called post-training methodologies, fine-tuning, etc. That is literally with your own private data, and that changes how the LLM behaves in answers with the data that you have. So you hit the nail in the sense that yes, all the commercially available open source, they have really a lot of similarities, but depending on how you fine tune them, how you kind of convert them into tasks, you input more data. For example, there are LLMs that are ultra specialized in code generation LLMs. So they are really trained with a lot of code and doesn't make that much sense to have literature there. But if you have an LLM that you want for a chat type of experience, you don't want them to do that much code. You want them to do more conversational and emotional type of data sets. So you really hit the nail in the sense that yes, that's the edge or the competitive advantage that a company might have is the data that they own. And that's what they say data is today's oil because that's the most valuable asset in the industry right now.
Excellent. No, thank you, Victor, for those insights. Uh, many CIOs and CTOs are dealing with convincing their leadership teams to invest in
Mm.
AI or agents. Um, what would be your recommendation? How do they need to face the reality that some of the technologies are new, you need a lot of data, you may need certain amount of investment to learn and test and experiment. What would you tell them?
First thing, call me. I'm definitely going to help you. Now, besides that, the whole point is about the scoping, right? A lot of companies believe that you have a huge data strategy modernization, huge AI strategy modernization, and you basically need to overhaul the whole company. That's when, at least in mass, we recommend that you take a slice of the pie. And what's a slice of the pie? A full process. So you identify what process uh, goes into what type of data. So you have the data identified. What are the tasks that you need that process to achieve? And what will be the KPI that you are going to monitor? If you have those three things, you don't need to basically boil the ocean to have AI. So it's all about scoping. Can you scope something that is important enough to the company, but also small enough that you can pay for it? Because the whole point here is that you want to lower the barrier of entry as much as you can, one. And second, you want to be as specific as possible so you see the KPI that is going to move. Because at the end of the day, imagine that you do a POC and you are like, oh, I can increase my user base 10%. And you see that in the POC, and that becomes a business question. Okay, do we want to grow our user base 10%? Probably everyone would say, yes, of course, if you're a product company. So those are the type of discussions that you want to have and that I recommend having with your leadership team. What are the KPIs that you want to hit? Is this small enough as a project so we can fund it? And if so, let's make it happen.
Excellent. Excellent, Victor. Um, maybe let me check if there are new questions in the chat. I didn't see any new one. There is one, or there was one about RPA, but I think you already covered that one. Should the
Okay.
RPA, worry about agentic workflows? I think you covered that one. Um, many companies and industries, typically the architecture of those organizations is a mix of buying products and building products, right? Or renting products, right? If it is software as a service. Uh, how do you go about finding the right balance between building models or AI products versus buying or software as a service, some solutions that are in the market? What would you recommend to use as a criteria to build versus buy?
I mean, the first thing is that I would say if you are not a OpenAI or what we call AI foundational company, don't try to train your own LLM. Like you need millions of dollars to do that, postdocs and PhDs in order to make that happen, right? So that's kind of the logic. And then it becomes, what is your core business? And what are the tasks that will allow your core business to grow the way that you want to? That's when we say, for example, customer segmentation. Everyone wants to know their customers, but not everyone needs a fraud detection system that is top notch. If you're a payment processor, probably fraud costs you P&L. So that's why fraud detection becomes something vernacular, and probably you want the best in class. And sometimes your data is so particular that the best in class is only built by you and your data because no commercial available solution will be there. But at the same time, if you inside of the payment processor, you want to build campaigns and you want the designers to have AI, you need to build an AI model to create images? Probably not. You want to buy that, right? So then it becomes this ecosystem of what are the tasks that I want to achieve? Are they core tasks or non-core tasks? They are revenue moving, non-revenue moving, and that's hopefully when you start making the decision. Also, something that I would recommend is try to see the problem from the data angle, meaning that do I need a lot of data to solve this problem, or or it's okay with only 1,000, 5,000 data points? Because if the answer is do I need a lot of data, probably you want to rethink that, because a lot of data means a lot of training, and a lot of training means a lot of money into the AI model. But if your size is 1,000, 5,000 data points, 10,000 data points, and you with that can do good stuff, that will be a good place to also build a model, because it's small enough that it becomes a cheap model to build. I hope that goes a little bit into giving this a little bit of light.
Excellent, excellent. Thank you, Victor. So we're right at the end of the webinar, and really thank you for joining us. And on behalf of the team at Mass Global Consulting, please thank you all for your time and engagement and for your questions. And take care. Have a good day, and we see you soon in the next webinar.
And thank
Bye.
you, Marcelo. Yeah, really have fun having
Oh,
this
me
with you.
too. Thank you. Thank you. This was amazing. I learned a lot. Thank you very much.
Yes, sir. Bye.